Hi everybody, and welcome to another part of the Solidity tutorials. In this part we're going to write a more complete kind of a decentralized exchange contract in a way that we can exchange our Ethereum with a kind of ERC20 token that exists out there on Etherscan, so that we can get the address of the contract of that token and enter it here and swap our Ethereum with that token and then withdraw the funds. So again, this is a kind of a minimalistic kind of exchange. This is not at all a realistic kind of a decentralized exchange, and you shouldn't use it for commercial purposes. This is just for education purpose. So first of all, let's get back to our contracts dex.sol and save this in order to compile it and deploy this in order to see how it worked. So here we used to deposit some amount, and then instead of the trade we had this seller. So instead of the seller, we want to set the address of the token so that we will be able to actually swap our Ethereum with that kind of specific token. So this becomes this makes our decentralized exchange much more realistic, and here we don't have the seller. Instead we have the address of the token, so that once we actually swap our token with the Ethereum will go to the token of the contract, the address of the token contract, and we will get the tokens that we want. But notice that here, because this is a virtual environment, we do not actually get the tokens and we do not pay the tokens. So this is just for practice and educational purposes. So with that said, let's get started with our contract. Let's head over to the file explorer and create a new file. I'm going to call this dex2.sol, and here, just like the previous one, we're going to copy and paste the first two lines. So to continue, we will first of all, before writing the contract, we will write the interface. So we'll get the interface of IERC20, which is the ERC20 interface, and here we will have the function transfer that gets the address of the recipient and uint 256 amount, external returns bool, so this is inside of the parentheses, so bool, and there we go. So okay, we do not need, this is not a function, just an interface. So this is a kind of a virtual interface, not the real one that we get from the OpenZeppelin. This is just a very simple kind of like ERC20 interface that only transfer is defined inside of it, because we only need the transfer to get the tokens. So right now we'll write the contract. So notice that this is just a practice of the contract. So in the real world, we do not write this. We get the real ERC20 from OpenZeppelin and then write that swap contract or decentralized exchange contract. Notice that some people say, okay, there is a difference between the swap and decentralized exchange, but these two can be used interchangeably. And another big difference, swap is when you want to have a swap between two tokens or a token and a coin, and decentralized exchange is a complete system where you have a lot of swaps inside of it. So contract decentralized exchange. So we'll get the address, public owner, and we have a mapping from the address to the uint 256 for public address, for public balances, just as always. We'll do this for the transfer. So address to uint 256, public balances, here we go, and then we'll have event deposit, event of the deposit, and address indexed account, indexed account, and it's uint 256 amount, 256 amount. Here we go, and then another event for withdrawal, event withdrawal. So actually with the capital letter, and address indexed account, address indexed account, and the uint 256 amount, uint 256 amount. Here we go, and event trade, event trade, address indexed buyer, address indexed buyer, address indexed seller. So let me check again. Here we do not seem to have a seller, so okay, we write it here. So address indexed seller, but this is just for the events. Notice that actually we have the instead of our construct, actually instead of the fields that we get inside of our trade, we have the actual address of the token address instead of the seller. So anyway, this is a kind of a trade between the seller. So the seller is the token address. So that's why here I've written seller, but so we can keep this here to uint 256 amount, and also uint 256 price, amount and price. So this is up to here is exactly the same. Also for the constructor is exactly the same as the previous contract, but we're writing them line by line for you to remember it and also see what's going on. So constructor and okay, so the owner is the message.sender, msg.sender. Here we go, and that's it for the constructor. So here we'll write the receive and fallback functions just in a bit different way. We used to write them at the end without anything inside of them, but right now we'll write the deposit inside of them. So receive, external payable, deposit message sender, deposit msg.sender, and also fallback external payable, fallback external payable, and here we'll also deposit message value, deposit the actually in the previous one, not the message.sender, message.value, and this is the balance that we've entered the contract. So msg.value, here we go. And then we'll have a function for depositing. So function deposit uint 256 amount and public payable. So public payable. So we'll require that the amount be greater than 0, and otherwise we will show to the user invalid deposit amount. Also the balances of the message to the sender. So balances of the msg.sender plus equal amount. msg.sender equals to plus equal the amount, and we'll emit the deposit event, emit deposit, and it has the message sender and the amount, msg.sender and the amount. And here we go, this function is completed. So we'll continue the rest of this tutorial in the next video and complete the functions of this smart contract.